Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone, especially to Dr. Abdul Halim bin Abdul Latif, my lecturer for Seismic Data Processing QBB 4033. My name is Muhammad Alam Hakim bin Muakbal. I'm a petroleum geoscience student in University Technology Petronas. So for today's presentation, I will explain and discuss about the residual static correction in seismic data processing. As we all know, in industry of oil and gas that use the seismic for the exploration phase, static correction will also always leads to losses of seismic resolution, both temporal and spatial. Static correction also are the sources of serious structural and stratigraphic interpretation error. So these uh, will lead to the serious issue in terms of interpretation of the seismic letter, and will always lead to the misinterpretation in the after processing the seismic data. And also we know that the static are the big challenges for the processing of deep reflection seismic data with several factors. First, rock surface acquisition topography. Second is non-planar factors, which will give the different seismic data output later. Third, variation of underground water table. Fourth, near surface low velocity layers. And lastly, lateral variant velocities of weathering layers. When we talk about static correction, it is a correction that the geophysicist in the field applies the data correction after the data sorting. For recent years, some of the static correction which subdivided into several groups. For example, the residual static correction, which applies after the NMO, or so-called as a normal move out. But some of them applies before the normal move out, and others will applies without any NMO correction. Cox 1999 and Sheriff 1991 have defined static correction as a corrections that apply to the seismic data to compensate for the effects of variation in elevation, weathering thickness, weathering velocity, or a reference to a datum. So in other words, the static solution or static correction will correct the time shift that caused by the topographic undulation, velocity anomalies in the near surface, and delay time travel of the reflection signal through the weathered layer. As I mentioned just now, static correction have subdivided into several groups. For example, the field statics, refraction static, tomographic static, and residual static. For the elevation, or so-called as a tomographic static, and the refraction static for short and long wavelength, and as well as the hub-hole correction, it known as the general static. But the residual statics stand alone as the residual static correction. So, what is the difference between the general static, which include the elevation or tomographic static, refraction static, and the hub-hole correction, between the residual static? So, in general static, we always apply the correction in the early stage of processing, while the residual static are applied later in the stage of processing. General static correction are applied for topography and influence from the weathered layer, and the residual static are normally implanted to the data that were applied after the general static. And general static always solve the problem for only a certain part, while the residual trace delays by the cross correlation between the inputs of the data. For general static, it needs small shift correction for a certain area or a region, compared to the residual, which compute the surface consistent static shift from the trace delay that we get from the cross correlation from the input. And lastly, general static used for the correction for long period of statics, while the residual static correction are used for a short period of statics. For the past years of the residual static correction, actually this correction will apply in the early stage of the processing seismic data. Hilleman et al. 1968, Garotta and Muchen 1968, Disher and Aquin 1969, Irvin and Wally 1969, as well as Hagi and Zelle 1975, presented method for the residual static question by using the automatic residual static. But then, Tanner et al. 1974 clearly formulated and commented the early method and formulate the mathematical model of the statics problems and discuss in detail about the standard mathematical algorithm by using the Gauss-Seidel iteration algorithm. Tanner et al. Also suggested that the residual static question to apply after the NMO corrected data. In 1976, Wiggin et al. Stated that residual static analysis only can resolve the short wavelength content of the travel time distortion. And compared to the long wavelength, the trend is limited by the spread length of the recording cable of the seismic during the acquisition data. So in Ronen and Klebout 1985, instead of depending on the estimated time shift, they developed a method called a stack power maximization, which updates the reference traces and time shift estimation. After hearing and discussing about the commented by Tan et al. In 1974, Chan, which suggested to apply the correction after the NMO corrected, Chan and Stewart 1996 suggested and show the application of the FX prediction filter in each offset to enhance the signal coherency and filter traces used as reference for static estimation. This is because the signal coherency between the traces is common offset domain is independent to the velocity influence, which does not need the velocity information and can be applied before or after the NMO corrected, which contradict a little bit compared to the commented by Tanner et al. In 1974. In 1997. In 1994, Jan et al. And Lander 1998 presented a method that used the pre-stack depth migration followed by its inversion, or so-called as the demigration, as the reference traces. But it is difficult as this method is a high velocity dependency compared to the past method. And the recent one, 1998 by Lenner, suggested to estimate the both velocity model and the residual static correction in the iterative way using the equivalent offset migration EOM. So the basic methodology that we use for the static correction is the first one to build the reference traces, use the reflection information or the seismic signal to form the reference traces that have less or no travel time deviation due to the near surface anomalies. And then in steps 2 to compute the cross correlation between the seismic traces and its corresponding to estimate the time shift between them. And lastly, to apply the decomposition, the estimated time shift that we get from the steps 2 on every seismic trace in the surface, consistent source statics and receiver statics. They noted for the steps 2, step 1 and step 3, it may be different in approaches, while the method for steps 2, which are only for the cross correlation of the seismic input, will be similar to all the methods. For example, if the methods are requiring about the NMO, normal move up correction, so for the step 1 and step 3, it will include the NMO correction. But if the residual, if the static correction is not require any, if the methods does not require or use any enamel correction. It will not use any enamel correction in the steps. So the main objective for applying the residual static correction, the first one is to construct a realistic model of the shallow subsurface by inverting the refracted first break arrival, which will use for a reference or a datum to bring other seismic signal, which will apply the time shift correction to bring the receiver or the shot points to this datum, and to apply the residual static correction to remove the distortion that due to the near surface velocity variations, and as well to improve the signal to noise SNR ratio. As you can see at the bottom, there's two different types of model, realistic model that we can use, which on the left side is the simple model. It is by applying the constant velocity in the shallowest near surface layer, and while on the right side, the advanced realistic model is to apply the statistical velocity gradient is computed from the ABDUL data in dune area and is applied to the shallowest layer. So for the real event example in my presentation, I would like to bring out one of the examples that have been done in the onshore Niger Delta Basin, which is located at the southern part of Nigeria on West African continental margin. This study the seismic data were acquired by the Department of Physics by University of Port Harcourt in Nigeria. The area covers approximately 211,000 square kilometer, and the data used in the study was 3D pre-stacked onshore seismic data. They used the Getco Vista software for the processing of the seismic data. This seismic data will consist of the 6 residual lines navigate in north-south direction and the source line in east-west direction. As you can see in the black square here, it indicates the study area that were studied by the Port Harcourt University. For this study, the static correction is estimated from the slope of the first breaks and the layer thicknesses from their intercepts of their type axis and corrects relatively large near-surface structural anomalies. As we mentioned just now, the static corrections can be subdivided into two groups, which are the general statics and the residual statics. For this event, it apply both of the statics, which are the general, comprised of the uphold correction, the elevation, also called as the tomographic, and the refraction, as well as the residual static. So for the uphold correction, the replacement velocity were about 1,750 meter per second, which obtained from an uphold survey. The elevation, or so-called as tomographic statics, are ranging from negative 0.5 millisecond to about negative 1.3 millisecond, while the reflection static for the short wavelength and the long wavelength were about negative millisecond to negative 40 millisecond. For the residual statics, the value are about 20 millisecond to negative 20 millisecond. So this is the example for the elevation statics. This is for the refractions for long wave statics and the reflection for short wave statics. So after applying the static correction, let us see the differences between the before and after applying the static correction. As you can see, for this, the short gather 4,838. The left side is the data that before applying the static correction, and the right side the data that after apply the static correction. As you can see, the lines, the seismic line were nearly hyperbolic, and which will ease the interpretation by the geophysics later. And for this example, short gather 4,712, on the left side, the seismic line was scattered and not hyperbolic, which difficult for the geophysicists to interpret and to to determine the interpretation. But on the right side, after applying the statics, the seismic signal were nearly hyperbolic, which and more continuous compared to the left one. So after some studies between the historic and the recent papers between the residual static corrections in this presentation, we can say that they have some of the current debate, and for future direction that will lead to a better technology in terms of the residual static correction. For the first, it is the cycle that we use is limited to plus minus 10 millisecond only. And number two, it took more time compared to the conventional methods for calculation to cool down the potential energy of the particle in the system. So in hope, uh, in the future, we can have a better technology that can overcome this debate, that the cycle skip will expected to have a broad range, and it will took less time to increase the efficiency in the processing data phase for any exploration project for geophysics. After we have studied the theory and the methodology as well as the example of applying the residual static correction, we come into a conclusion that the application of static corrections to remove the irregularities from seismic reflections records and makes them near hyperbolic in order to ease the interpretation of geophysics later. The proper static solutions can improve both qualities and resolution of the seismic sections. It also provides a high resolution solution, the simple near surface solutions. Next, the reflections event after applying the static correction are even more stronger and more continuous compared to the one that does not apply any static correction. So for this, application of the static correction are critical for the interpretation during exploration for hydrocarbon and other geological targets. With this, it marks the end of my presentation about the residual static correction. I would like to say many thanks to Dr. Abdul Halim bin Abdul Latif for assisting me and teaching me in Seismic Data Processing QBB 40T3 during my final year degree in University Technology Petronas. Not forget to mention our beloved lab GAs and lab technician for assisting me and help me throughout the semester as well as during the lab session. Don't forget to like, share and comment.